Calculus students. For those who really want to learn the actual pre-cal stuff, it's not about chapter 1 through chapter 7. The actual pre-cal stuff is starting with chapter 8. It's all about like vector, polar, parametric equations. So something that we talked about for the previous video already. So this one is actually linking to Calculus 3 for those who are going to be taking Calculus 3, which is called the multivariable calculus. So for next year, Calculus 1 and Calculus 2, which is called Calculus A, B, and BC, it's all about limit, um, derivative, and integrals. But once you get into more complicated calculus stuff, you'll get into vector, the component vector, so the vector force, and also you'll get into double integral, double partial derivative, triple integrals, and also you'll be learning about the Green's theorem, and also learn about the Laplace theorem. Okay, so there's so many things that you'll see in Calculus 3. So I would say that pre-cal it's really critical. So according to getting into Calculus 1, Calculus 2, especially for like a lot of preparation for Calculus 3. And most uh, most times, a lot of teachers skip that the vector stuff in pre-cal, especially for student taking regular pre-cal. But for honors, pretty much the teacher covers all the stuff like from chapter 1 all the way up to the limit, like the introduction of calculus. So today we want to talk about a geometric and algebraic approach to vectors. So vectors, so we do have a scalar. So the definition of a scalar, that means it's a real number constant. So what a vector is, it's a directed line segment. So you guys do remember the ray in geometry? So it shows the one of the initial point, and it shows one directions. Okay. And the good thing about the vector, so it shows the magnitude, so it has the length. Okay. So the magnitude, it shows the length. So it shows how long that the vector is. And the direction, it shows the angle formed from a reference direction. Okay. So notice that the location does not matter for a vector. So let's say that the vector like this. So it shows the initial point and the terminal point. So the angle, it's always consider the one bounded right between the horizontal axis and the terminal side. So it looks like the angle here, it's about 30 degree, and the angle here, since this one, the vector is all straight, so this one would be considered 0 or 180 degree. So vectors normally can be written like this with the arrow on top of the letter. So vector u equals vector v if they have the same magnitude and direction. So notice that the vector u would be written as vector u or as bold-face u or u. So 0 vector, so 0 with the vector, the arrow, and 0 vector plus vector u equals vector u plus 0 vector, so it's the same as vector u. So a vector with 0 length and the additive identity, so negative vector u, so therefore vector u vector, so that it's pointing in the opposite directions. So one is going this way, the other one is going back to the opposite direction. A scalar multiples of vector u. So let's say that a constant c times a vector u. So where c is a real number, so it means that we have a vector in the direction of vector u, but scale in length. So for example, so let's say we have a given vector u, so it's like this long, and then 2 times vector u, so that means it's going to be twice as long as the original one, and then half of it, it's only half of the original one. Okay, so this one, it shows the length, the different length. So vector addition, so we do have vector u plus vector v. So let's say we do have those two vectors, so one is going this way, and the other one is going that horizontally. So once we combine them together, so started with vector u, and then vector v, and then whatever the initial position that you have, you want to connect it with the final positions, or the terminal point. So the initial point connected with the terminal point of the resulting vector. And then once you connect it, so then that would be considered the sum of vector u plus vector v. Okay, so here's another way to manage this. So let's say that we start with vector u down up here and then vector v down the bottom. So once we connect it, so you want to draw the parallelogram. So the upper vector v, same direction, it's parallel, and then another parallel vector u, and then once you connect them, so this one is from the initial positions to the final position. So in geometric meaning, so this one is just making the diagonal. So place that vector u plus vector v, so tail to head. Then connect the initial point to the final terminal point. So here's another approach. Place vector u plus vector v with the coincident initial point and create the parallelogram. So vector u plus vector v, it's a vector from initial point to the opposite vertex of the parallelogram along the diagonal. Okay, so now let's do some example for this. So let's say express w in terms of u and v. So given vector u, vector v, so once we connect that the initial positions and the final position of the resulting vector, so then we'll get vector w. So this one is showing that vector u plus vector w, so that equals vector v. Because we started with the initial position of vector u and then vector w, the final terminal point. So once we connect it, so this one can be expressed in terms of u, w, and v. So showing that vector u plus vector w, so that equals vector v. So draw w, where w equals v1 plus v2 plus v3. So here's v1, v2, v3. So started off with v1, so that's the vector. So from v1 to v2, and then v2 to v3, and then this one would be v3. So again, initial positions to the final terminal point. Okay, so now let's do some examples. That's a little bit more complicated. So Mart pushes on post in the direction of south 30° east with a force of 60 pounds, and then pushes on the same post in the direction of south 60° west with a force of 80 pounds. What are the magnitude and the direction of the resulting force? And for those students taking trig, so that's something some teacher probably have talked about already. So this one, it shows the vector. So it shows the bearing angle, and also shows that the magnitude of the vector. Okay, so what we got here, so we got the first direction, south 30° east. So we're just going this way. So south 30° east. It's a bearing angle. And then the other direction, what we got is south 60° west. Okay. So, but the things that we don't have the exact same magnitude, we do have two different kind of magnitude here. So one is 60 pounds, and the other one is 80 pounds. So imagine that this one is just like a right triangle, because 30 plus 60, that's 90°. So one is going this way, 80 pounds, and the other one is 60 pounds. So in order to find out the resulting vector, the force, so that means we're using the Pythagorean theorem, which is 100 pounds. And in order to find out the direction, the way to find the direction, we're using tangent, inverse of tangent. So theta, so it's arctangent of 60 over 80, because that's opposite over adjacent. So arctangent of 30, 60 over 80, so we do have arctangent of 3 over 4. So this one is not one of the special angles, so we're going to find out exactly what that is. But keep that in mind, 60°. So 60°, it's constructed by theta plus alpha. Again, 60, that's just the bearing angle. But we still need to use that, the reference angle, alpha. So 60, that consider alpha plus theta. So in order to find out alpha, so 60 minus theta. So 60 minus arctangent of 3 over 4. If try to do that on the calculator, so we'll get alpha equals 23.1 degree. So the resulting force has a magnitude of 100 pounds with a direction of south 23.1 degree west. Okay. Again, the post right here, so that just shows the diagram, part of the diagram, but also shows the direction is facing to the south. Okay. But in order to find out the directions of the resulting vector, so we need to find out that alpha, the angle. Okay. So now let's look at that, the other example we have. So a ship is sailing due south at 20 miles per hour. A man walks west across the deck at 3 miles per hour. So what are the magnitude and the direction of the velocity relative to the surface of the water? So if you try to roughly draw the diagram, so here's the person, so it's walking 3 miles per hour. And since we do know that the ship is sailing due south at 20 miles per hour, so just draw the diagram more precisely. So here's what we got. So the man is walking to this way, so with the vector, so it's 3 miles per hour, and the ship is sailing down south, so 20 miles per hour. So we do see that the angle here, theta. So in order to find out this magnitude, the new vector, so we're using that the Pythagorean theorem, so which is 20 square plus 3 square, and then square root of the whole quantity, so we got 20.2. So in order to find out what theta is, we're using our tangent of 3 over 20. Again, it's opposite over adjacent. So we'll get 8.5 degree. So the resulting velocity would be 20.2 miles per hour. And then the direction would be south 8.5 degree west. Because that's going down this way. So south 8.5 degree west. So notice that we're assuming that the surface of water is still, okay? So the water is not moving. So the vector algebraic approach, so here's some of the formula that you guys need to know. So if we place our vector on a Cartesian coordinate system, so again, Cartesian coordinate system, so that means it's about xy coordinates, it's like an xy plane. So with its tail at the origin, and then its head will end at some point. So the point is called u1, comma u2, comma u3, and we say that u equals vector u1, comma u2, comma u3. So one is called the component form, and the other one is called the vector form. So if that's the Cartesian vector, the Cartesian form, so this one would be considered like x1, x2, x3, along with y1, y2, y3. So u1, u2, and u3 are called the component of u. So this one can be written as u1 equals v1, u2 equals v2, and u3 equals v3. If and only if u equals v. So using that the property, the addition property, so u plus v, then that'd be u1 plus v1, comma u2 plus v2, comma u3 plus v3. So basically we just want to add those components correspondingly. If that's considered three-dimensional vector, then this one would be considered x1 plus x2, and then x3, x2, well x1 plus x1 plus x2, and then y1 plus y2, and then y3. Excuse me, let's put it this way. It's x1 plus x2 plus x3, and then y1 plus y2 plus y3, and then z1 plus z2 plus z3, if that's a Cartesian form. So negative u, so with the vector component, so then that'll be negative u1, comma, negative u2, comma, negative u3, and then multiply by the constants, then that'll be constant times u1, comma, constant times u2, comma, constant times u3. If that's a zero vector, so that means nothing, so the vector will be it can be written as 0, comma 0, comma 0 with the vector component form. Okay, so here's the theorem, things that you guys need to know. The commutative property of addition of the vector, so u plus v equals v plus u. And then associative property, so u plus v, the quantity of u plus v plus w, so it's the same as u plus the quantity of v plus w. And then the additive identity, so u plus 0, so that equals 0 plus u. And then the additive inverse, so u plus negative u, then that'll be 0. So the associative property, so a times the quantity of b times u, so this it's a multiplication of the associative property of the vector. So it's the same as a quantity of a times b times u. Or this one can be written with the distributive property of a scalar multiplication. So a times the quantity of vector u plus vector v, so it's the same as a constant a times vector u plus a constant a times vector v. Or the scalar a plus b, the sum of the scalar a plus b times u, then this one can be written as a times u plus b times u. And then the identity, so 1 is the scalar multiplication identity, so 1 times u is the same as u. In order to find out the magnitude of three components, so the magnitude of u can be written as square root of u1 square plus u2 square plus u3 square. And then the magnitude of c times vector u, so it can be written as the absolute value of c times the magnitude of u. Again, magnitude of u can be defined by using the Pythagorean theorem. Again, absolute value of c. And then if you see the double vertical bar like this, so it's called the magnitude and the length of u. So the notations, the magnitude of u, or this one can be written as absolute value of vector u. So now to look at that, the other example we have right here. So let vector u equals -1, 5, 2. So as you can see, that is three components, x, y, z, and find magnitude u and magnitude of -3 times u. So also find a vector such that the same direction as u, but with the magnitude equals 1. So this one is called a unit vector if the magnitude is 1. So how do we define the magnitude, the unit vector? So we're going to find out that later. But let's define the magnitude of u first. So again, using the formula that's listed above. So we're using that square root of u1 quantity square plus u2 quantity square plus u3 quantity square. So using the Pythagorean theorem, we do have square root of -1 quantity square plus 5 square plus 2 square, which is square root of 30. And also this one can be simplified by using the calculator, but just leave it like that. It's a non-calculated problem. And then with the magnitude of -3 times vector u, so this one is 3 times root 30, because absolute value of -3, so that just shows you 3. Again, magnitude is always considered positive because that just shows the length of the vector. So if you see that the little cap like this, okay, like a little caret sign. So this one, that means cap u, it's a unit vector, a vector with length 1. So the way to find out the unit vector, so by definitions, the formula is the vector u divided by the magnitude of vector u. So the original vector u, it's -1, 5, 2, so it's over root 30. And then from here, we're using the distributive property of vector. So we got -1 over root 30, comma, 5 over root 30, comma, 2 over root 30. And for some student might be saying that, can I rationalize it? Yes, you may. So that shows the unit vector. If you try to use the Pythagorean theorem for this unit vector, so eventually the length is going to be 1. So let's say that you take the square root of -1 over root 30 square plus 5 over root 30 square plus 2 over root 30 square. So once you sum up all those three numbers, quantity square, and then take the square root, you'll get 1. That's why it's called a unit vector. Okay, so any questions, any comments? So please put it up on my YouTube channel. So I'll see you guys next time. All right. Thank you for watching it.